Hi, my name is David Siegel, and I'd like to welcome you to a mathematics course for political and social research. The intent of this course is to provide you with the basic information you need to go on and learn methods in political science primarily, but also in social sciences more broadly. These methods primarily consist of statistics or econometrics, depending on where you take it, and game theory and formal theory. This class uses a textbook written by Wilmore and myself, which is intended to provide a sort of core competency in mathematics that you're to use both as an introduction to the mathematics you need to know before you start taking methodology courses in graduate school, but also as a later resource for you as you go on in methodology courses to look back to see how certain topics and concepts in mathematics work. It is broken up into multiple parts, each covering a different aspect of mathematics that mirror existing classes in some way. But it is different from most existing math courses in a couple of important ways, and this applies to both the textbook and also this course. One, it is primarily focused on students going in with interest in political and social research. And this is important because oftentimes people with these kind of interests don't take a lot of math as undergraduates, aren't primarily focused in math because the substantive interests, quite rightly, are attached to topics that don't obviously lend themselves to math, and they're often not taught with any kind of quantitative or sort of formal theoretical approach. And because of that, people interested in these topics don't necessarily learn the background they will later need if they want to go on these topics, because there actually is a fairly large bifurcation between standard undergraduate education in political science, which may have a course on sort of quantitative methods, maybe two, maybe there's a game theory course in there, but not a lot of focus on really on statistics or game theory, for instance. And then you get into grad school, and in grad school there is a lot of focus on, in many places, a lot of focus on statistics, game theory, and these kind of tools designed to help you derive inferences about the way the political world works, the social world works, and derive theories about how the political and social worlds work. So there's this separation between the undergraduate and the graduate educations, and people come in oftentimes without sort of a real firm background in mathematics. The way this book and this course is structured is intended to start at the very beginning without assuming almost any knowledge beyond stuff you might have learned back in the beginning of high school or middle school, and take you from there talking about sets and functions and numbers and the very basics of mathematics, and take you through there to the point where you can reasonably be expected to take your methodology classes in graduate school and feel comfortable with the tools, the mathematical tools they will employ. So along those lines, the book and this course will go through from the very beginning, as I just said, and also try to fill in the steps. It's particularly true for the book, which tries to fill in all the steps necessary to get from point A to point B in the mathematical logic, and not skip steps, as is so often the case in math books, right? One of math books' biggest flaws, frankly, is the overuse of words like obviously and of course and clearly, which hide a whole lot of steps. And it's very difficult for someone coming in without a real firm background to follow those steps that are just hidden or elided. The goal of this course and this book is to not skip those steps, to lead you through all these interim steps, and thereby hopefully make things clearer. Similarly, another issue with sort of going into and just taking math to try to get caught up is that you learn a lot of topics in math classes that almost never come up in political science or social sciences more broadly, and this tends to frustrate people whose primary focus is not mathematics. In this course, we're going to be focusing on the sort of core competency in math, the stuff that you most need to know. And I'll explain in most cases, certainly the book will definitely explain in all cases, and I'll explain as much as I can in this course, why you need these particular topics, sort of what the goal is. Which sort of brings me to the second major point of this book, which is that it is intended to illustrate for you why you need to know these topics, right? So it is a subset of topics chosen from all topics that could have been discussed, and the topics chosen to apply to particular problems that are commonly seen in political and social research. And we also go and then explain what these topics are and how the math you'll be learning applies to these topics. So instead of just being an abstract idea you're supposed to learn this math, we're giving you a reason to learn it. So those are the major differences here between this course and the book it's drawn from, and sort of other courses you might take or other selection of mathematics courses you might take. Now, it's also useful to compare this introduction, sort of this approach to the existing approaches. Primarily, graduate schools use two different approaches to getting students the math they need to start off taking these methodology classes. One approach is math camp. I think it's fair to say that most math camps don't work very well. That's not at all a knock on the people teaching them who work very hard to make them work well, but rather a math camp is typically a 1 or 2 week event in which you're supposed to learn an enormous amount of math in a very small period of time without doing a lot of problems, without doing a lot of practice, and that's extremely difficult for anyone to do. It's pretty much an impossible task to get someone to sit down and learn all the math you need to do in 2 weeks. So primarily what happens is a subset of the relevant math is taught, and students try their best to follow it, but they've just come to grad school. It's difficult. There's so much there, and a lot of it just goes right past them, and that's completely reasonable. This is meant to help out those situations by allowing students, before they start the programs, to sit down and have as much time as you want to go through all the material. There are over 30 hours of lecture videos as part of this course. One of the good parts about this set of lectures is that you can pause whenever you want. You can take lectures at your own pace. You can pause whenever you want. You can stop and start. If something is difficult, you can take a break from it and come back in a day or two. That's all fine. You should have a couple of months at least, to go through this at your leisure during the summer when you should have ideally less to do than you do in the very, very busy first orientation week of graduate school. So that's one benefit. And I should advise at this point, I tend to talk pretty quickly when I get going. I'm speaking into a webcam right now, so there's no one to stop me from speaking too quickly. I try when to speak clearly, to speak slowly when I can, but I often speed up. I highly advise you to pause early and often to make sure that things don't go past you, because I am speaking too quickly. I've tried as much as possible I have a tablet here that I've been using for the most of the videos, all the videos except for this one, and I have tried as much as possible to keep things on the same page, so that you can pause and look at that screen and work through stuff yourself before moving on in the videos. And I highly advise that as a methodology. To watch these things, pause frequently whenever you have any confusion, and make sure you at home can work through the stuff I've worked through on the tablet or talk through. Okay. So that's one benefit to this approach. And I should say, beyond the 30 plus hours of lecture videos, which have me in a corner, by the way, in the whole screen. I'm in a corner, and there's a tablet screen for most of the screen that you'll see. There are also a few hours of problem sessions and some problem sets to practice on. The problem sets will be available to you on the webpage associated with this book. And the problem sessions are in the same location that you will find these videos on YouTube. And in these problem sessions, I work through some sample problems, and the problem sets provide additional problems to work through, and the solutions will be available to you in some fashion. And that also help you reinforce the learning you're getting from the videos, because practice is really the only way you learn math. In fact, I should say that people tend to come into these math courses with a great deal of fear and anxiety, because oftentimes math is associated with this sort of abstract, you either know it or you don't, you either get it or you don't get it, and that's frankly garbage. Most of the stuff is just practice. Now, that's not to say people won't get it faster and slower. A lot of this is background and potential anxiety. That's completely true. However, if you work at this, you will get it with practice, but you must practice, and there will probably be some wall you hit that you won't get something, and the only way to break through that wall is with practice. And this is intended between the lectures and the problem sessions and the problem sets to provide you with that practice should you choose to take it. Right? As a video course, this is very much dependent upon your effort level and your desire to learn the material. If you just kind of skim through the videos, you probably won't get much out of this. But if you sit down and try to work through them all and work through the problem sessions along with me, and then work through the problem sets yourself and check your answers, I believe, I hope is that you'll get a lot out of this course and it will be helpful to you. Okay, so that was a long discussion about relative to Math Camp. And I think it's fair to say I think this is a superior option to Math Camp as it stands, although it is helpful to have some time time to talk to someone live about this stuff. I'll get to that in a second. The other primary way of people learning mathematics is through a semester-long class, which some schools have. Here, I'm not going to argue this is better than a semester-long class. It's probably not. It has some benefits in that you can pause and not have to be, if you get stuck, you don't have to just watch as the professor keeps talking. You can stop them forcibly and then make sure you can catch up to the material. So that's a positive. But you can ask questions as you could in a lecture. Because of this, I advise that for those using this course as a substitute for Math Camp or whatever, I advise the assignment of one or more teaching assistants or faculty members to answer questions during the semester via email or Skype or whatever. The way we're teaching this course right now, we have TAs assigned over the summer to help answer questions. At the end of the summer, both the TAs and I will be available to answer questions live and discuss some problem areas. Okay. However, in a lot of ways, a full semester course it will be superior because you have even more time potentially to go through this stuff than a summer, and you have a live professor to answer questions back and forth. However, even in there, this can be a useful course for this situation as a supplement. People learn different ways. Some people find things more or less confusing. Some people find things more or less clear, depending on how the material is taught. Teaching in different ways can be helpful for different people. And the more different ways you see material, often the better you understand it. So this can be a complement to existing courses, existing math courses, even during a whole semester. This could be another source of training, another source of material, another approach to teaching the material. Okay. So, and that's most of the sort of the broad strokes of this thing. Again, in briefer, the point of the course is to provide you with the background you need to do well in future methods courses in your graduate education, and to better understand papers and to better be able to contribute in the way you want to contribute. Because as it stands now, if you don't have the background, oftentimes people tend not to then go on learning more advanced techniques in statistics or game theory or other forms of formal theory or whatever. And that basically precludes them from doing research that they might have found very interesting just because their math background wasn't necessarily strong, and that frankly is not very fair. Right? You should be able to choose to work on what you want to work on based on your interest and not on the vicissitudes of your high school education. Right? So this is intended as a partial way of ameliorating that problem. So that's the broad strokes of why we're doing this. Now, in terms of the concrete nuts and bolts, again, on the YouTube channel for this course, you'll find the videos streaming, you'll find the problem session streaming. There's a website associated with this textbook, which also has links to this course, to the YouTube channel. and to this course, which will have problem sets available to you. And you should check back often as that's getting worked out as I speak. Now, check back often. Also, please subscribe to the YouTube channel. I will at times, via feedback, add various addenda to the lectures if I decide that a certain part is unclear or could use an additional piece of information. For instance, I already have an addendum on the last module in the first lecture, the very end of the first lecture, which I'm going to provide additional information, additional examples of necessary and sufficient conditions. These will be posted on YouTube in the same channel as before, and if you subscribe to the channel, you'll be updated for when any addenda appear. Okay, so that's the nuts and bolts there. In terms of the setup of the course, it matches very closely the textbook in that there are 5 parts to the course. And in most cases, there's one-to-one correspondence between the chapter in the book and the course lecture. There are 16 lectures, video lectures here. The first 2 lectures cover the first 4 chapters in the book. That's part 1 of the book on sort of preliminaries, building blocks, the more basic stuff that typically comes in a decent high school education but is often left out in realized high school educations, right? So things like sets and functions and continuity and so on. But even there's some topics that aren't always covered in high school. For instance, there's some basics on proofs and logic and so on. So that is the first part of the class. That's the first 2 lectures. The next part of the class is part 2. It's the next 4 lectures, and this covers calculus in 1 dimension. Now here is oftentimes the part where students trip up the most because calculus tends to be a sort of scary topic when you first approach it. So work as much as possible to try to build the intuition behind the tools. So there are actually 2 chapters on the derivative in 1 dimension. The first chapter is meant to build up the intuition behind the derivative. The second to show you how to actually compute derivatives. And then we build up integrals and then finally optimization in 1 dimension, which is sort of the payoff of that section. And that's part 2. That's 4 chapters in the book and 4 lectures in this video course. The next part 3, is probability. Whereas the calculus section is a fairly complete Calc 1 and 2 equivalent there. I mean, we're probably missing a few topics here and there, but a lot of it is covered between that and the building blocks. A lot of the Calc 1 and 2 classes covered here. Part 3 in probability is a more bare bones type of course. It gives you the basics of probability, and then in the first chapter and then in the next 2 chapters, sort of primer on discrete and then continuous distributions, respectively. This is not a complete probability course by any means, but it'll give you a decent basis for understanding future probability courses and future statistics courses. And that's a pretty self-contained part. The first 2 lectures on probability and on discrete distributions do not require any calculus at all. You can go through them earlier if you care to. The last part on continuous distributions require calculus to understand properly. Part 4 of the class is on linear algebra, and this again is a pretty complete linear algebra course. It also has 3 lectures in it, and both the probability and the linear algebra class match the same ordering in the textbook. And there's basics on how to just calculate with matrices and vectors. They require no background at all. You can start looking at that after the first lecture. You can go straight onto linear algebra if you wanted to. There's nothing required after the first lecture for linear algebra. So the first chapter, fun with vectors and matrices, is just about how to compute things with vectors and matrices. The next chapter goes into more detail. The next lecture goes into more detail on the core, on the basics, the background, the theory behind linear algebra, things like vector spaces and so on. And the last lecture in this part goes into more advanced topics of eigenvectors, eigenvalues, Markov chains, things that will typically not necessarily be observed by you in introductory classes in political science or social sciences, but will pop up in later classes on things like time series or stochastic processes and various topics, more advanced game theory classes and so on. And so you can probably skip that lecture in the first pass through if you're pressed for time, and come back to that when you reach these more advanced topics. That's part 4, and part 5 is the most challenging part. It's a multivariable calculus. Here is not a complete class at all. What I've done here is taken the typical Calc 3 class and we've sort of removed the parts of that class that just don't come up very much for political scientists. So things like volume integrals and surface integrals and line integrals and divergences and curls, all things that involve a lot of geometry that are very common in a subject like engineering or physics. Don't come up very much in political science, or I think all sorts of sciences, so we just don't talk about them. Instead, our focus is on understanding multidimensional functions, understanding the partial derivative, how to deal with the derivative that controls for other factors, and how it relates to things like statistical tests and statistical models, the linear model, and then looking at how to generalize the derivative and the integral into multiple dimensions. Most importantly, then, looking at how to optimize functions of more than one dimension under both unconstrained and under constraints. And then finally, how to deal with things like comparative statics and sensitivity analysis when you're looking at how some outcomes, some equilibrium outcome or some estimator varies with its parameters, and looking at how to implicitly differentiate things. This last part is the most challenging part, as I said, and does require all previous material with the possible exception of probability, but even there, examples tend to reference probability. So that's the setup of the book, and that last part actually deviates from the textbook a little bit in that split the first chapter of the textbook, chapter 15 of that part, into two different lectures. The first lecture gives you, just gives you the basics of multivariable functions and partial derivatives integration. This part is really important. And it's the kind of stuff that comes up really early in sort of your training, and therefore even if you want to skip the entire rest of that part of the last part of the course in the first pass, that part should really be done first. That's why I split it off to a separate lecture. The other three lectures are more advanced material that can probably be safely skipped right off the bat and looked at later on before you do things like a more advanced game theory class or more advanced stats classes. Okay. So that's the setup. Now, because listening to me talk for a long time in a row, even if I'm only in a corner, can be rough, even with the pause button. I've broken up all the lectures into multiple modules. Some lectures have 10 modules, some only have 3. The modules range from a little over 3 minutes to 40 minutes. They're basically split up by topic. This allows you to have a more natural way of tackling this course by looking at a module at a time. You can really focus in on a particular topic without having to get the whole thing at once. So you see the small part, take a break, make sure you can digest that fully, and then go back to the next part when you're ready. So each of these is broken up by module, and online there's a topic list, and each topic in each module has a topic title, so you can see which topic is in each module. Okay. Finally, this is a pretty long introduction already, and I apologize, but finally, in terms of how to go through the course, there are many ways to do it. Obviously, you can go straight through the whole thing if you want to. That's the most complete, obviously, way to do it. But there are other ways too. If you have a really strong math background, you'll find yourself probably skipping over the stuff in certainly part 1 and maybe even part 2 of the course pretty fast before you hit probability and linear algebra. If you have a weaker math background, you want to spend more time on the first 2 parts. If your primary interest is in, say, dealing with matrices and vectors and statistics, you might want to skip part 2 of the class completely in the first pass, do the first lecture, then skip on to linear algebra immediately, get a sense of the vectors and matrices and so on, and then come back, deal with the second part of the deal with the second lecture in the first part of the course, and then look at probability. The first 2 parts of probability. That'll give you a sense of probability and how to deal with vectors and matrices and data matrices and things like that without having to go through calculus first. So that's one way of approaching it, and then you can go through calculus later should you choose to. Another way is to leave off probability entirely if you have a really good, strong probability class happening early in your time in grad school. Just skip the probability section and do the other stuff first. The only thing that really has to be done is before you go on to the last 3 lectures in part 5 of the class, you should have everything else done already and solid. You're not going to get much out of those lectures without having a strong background in everything else. But other than that, you can mix and match quite a bit. And the textbook at the beginning, in the preface, we talk a little bit about different paths through the book. Those same paths are applicable to this video course as well. So I think that basically covers everything that's important. And again, watch back. If you subscribe to the channel, watch back to see if anything gets updated over time. And please do, if you have any feedback, please do feel free to send it. Send me an email. My email address is all over the webpage, the book's webpage. So feel free to send me an email and let me know, good, bad, and different, how things are going. If you have, advice or comments, I can't promise to incorporate all the advice and comments just because I don't have infinite time to update this particular one, but I do want this to be useful to as many people as possible, and I am interested in making it better when I can make it better. So please do let me know if you have comments either way, or tell me it's good. That's always makes you feel good too. Anyway, I hope this was useful. I hope you enjoy it, and I'll see you very soon. Thank you very much for watching.